Okay, so simplest form. This is what we kind of left off with the last time we were together on Thursday. And if you can recall, I kind of said you didn't really have to write all these notes down because we learn through listening, not necessarily through writing. So my game plan is to teach you how to do this. And then if you have to go back and use those use those notes for help, then we can do that. So let's try to see if this can make sense to us first, just by listening and learning how to do it. Okay, so the last time we were together, simplest form. And this is a critical lesson. You gotta know how to simplify fractions. This is something that you're gonna have to do, no joke, the rest of your life, okay? Even if you become an adult and you're just at your house cooking dinner one night. I mean, there's a lot of meals out there that your parents prepare for you for dinner that require you to use fractions to make that food. So I don't want any of you to think, well, I'll never use this. Sure you will, okay? Fractions are all over the place. So knowing how to simplify them, is very important. So we kind of touched on this on Thursday when we were together last, but to be honest, we touched on it kind of fast. And so I'm not really sure if there's real deep understanding on this, so I'm gonna kind of take some minutes of today's class before we go into the new stuff to kind of make sure that we get it, we know how to do it. All right, so to review our brains, what's a proper fraction? Somebody who I haven't spoken to today. What's a proper fraction? Lily.
A proper fraction is like a fraction say 10 over 12.
Would you say 10 over 12? Good. So her example of what a proper fraction is was something like 10 over 12. And she's right. What makes that thing a proper fraction, Lily?
The denominator is higher than.
Beautiful. And what do we know about all proper fractions? Are they greater, less, or equal to 1? They are always less. Excellent. That's a proper fraction. So if we were needing to take that fraction that Lily just gave us and put that fraction into simplest form, our note right here tells us that anytime we have a proper fraction, we use greatest common factor to solve. So if you remember on Thursday, I said that whenever you see a fraction, how do you know if you need to put that fraction in simplest form? You should kind of have this internal warning buzzer that goes off inside your brain when you see certain fractions. Lily gave us the example of 10 over 12. That's a great example. Because right now, your internal buzzer, your warning buzzer, should be going off. Why? Xander.
Because it's not in simplest form.
But how do they know that?
Because they're both composite numbers.
Thank you, go get yourself a piece of candy. They're both composite numbers. And whenever they're both composite, that's what makes your warning signs start beeping at you. You've got to put this thing into simplest form. So 10 and 12. Now there are some of you in this audience right now who can look at 10 and you can look at 12 and you can see the greatest number that they have in common. That's excellent. How many of you right now, don't say it, just by show of hands, how many of you can see the greatest common factor right now? All right, that's a large amount of you. However, there are some people who don't have their hands up. All right, put your hands down. If you don't know how, or if you can't see it, then what do you need to do? What do you got to do?
List the factors.
You've got to list the factors. So for those of you who think you know it, on the count of 3, say what you think it is. 1, 2, 3.
2.
2. I heard lots of 2s. Okay. So a lot of us believe that 2 is the greatest number that 10 and 12 have in common. But if we're not sure, we can do the work to help us figure that out. We can grab those tools that we've been taught in our little backpack of knowledge, and we can say, well, To find the greatest common factor, I have to list the factors of each number. So what are my factors for 10? 1 times 10. What's my other ones?
2
times 5. I'm going to have issues with this board again. 2 times 5, are there any more? No. Then I have to list my factors for 12. What are my factors for 12?
1 times 12.
6 times 3.
2 times 2.
2 times 6 and 3 times 4. Okay, so there's all my factors. If I look at the largest one that they have in common, I see very quickly the one that they share is a 2. So for those of you who saw it without having to do all that extra work, that's excellent. I want to get you to that point because this stuff takes time. It takes too much time to have to do all of that. And when you are taking a test, and you have to take that test within a certain amount of time, we don't want to have to really do things that's going to waste our time. Now, if you need it, do it. Okay, this will always get you to the right answer. So for those of you who are just pretending like you found that too, don't be a pretender, because then you're going to miss things on your test. It's more important that you get them right. And if you need more time, I'll give you more time. But I want you to get to the right answer. So if you need to list all the factors for help, do it. Okay? But now that we know 2 is the greatest common factor, Hallie, what are we going to now do? Excellent. You're going to literally divide the 10 that you had and the 12 that you got by your greatest common factor. 10 divided by 2 is?
5.
12 divided by 2 is?
6.
And that is your final answer. Okay? So, that's how you learn to simplify proper fractions. You're going to see lots of proper fractions in your life. Probably more of those than the other kind. Yes! But you got to make sure you know how to simplify them. Okay? Let's try one just to make sure that you know how to do this, okay? Give me a fraction, Raiden. Give me a fraction.
A proper
I want a proper one, please.
12 over 15.
Over what?
15.
That is so weird, Raiden. I made up a fraction in that room just a minute ago. That was my fraction I made up. Weird. Our brains are thinking the same. Simplify that fraction. Go. And some of you already know it. You don't have to really even show any work for some of you. You don't have to put the little like divided by thing there. That's just showing what your brain's thinking about doing. I just want you to tell me what it turns into. But you got to know what number they have in common first. All right. Greatest common factor is on 3 is what? 1, 2, 3. 3 is the greatest common factor. If I take each of these and I divide it by a 3, what do I get? 4 over 5. That's your final answer.
This is easy.
Okay. Are we good on that? Okay. Let's move on to what the other kinds would then be. So the other kind would then be those improper fractions. So how do I simplify an improper fraction? Well, what's an improper fraction? Max, what's an improper fraction?
When the numerator is bigger than the denominator.
Excellent. And we know that always improper fractions are greater, less, or equal to 1.
Greater.
They're always greater. And what will they always turn into?
Fixed number.
Mixed numbers, okay? So, the example below is 7 over 3. That thing is an improper fraction because Max just told me when the top number is bigger than the bottom number, that makes it improper. This thing should turn into a mixed number, okay? So this is where you're going to be doing what to solve. Shane, what are we going to be doing to solve this thing? Division, very good. We're not searching for the greatest common factor here. We have to divide, okay? So that means, and many of you are already doing this up here, which is great. But if you're not needing to and you're writing it out, that's cool too, okay? But this turns into a division problem. So your top number goes in your box. So 3 goes into 7 about how many times, Shane? About 2 whole times. When I subtract, I'm left with 1, okay? What happens to that 1 when I subtract? Shane, this is your problem. Finish it up.
Put the one on, put the one on fraction.
Please stop telling me. Yes?
Put the one as a fraction of 1/3.
And then the denominator is whatever my denominator was when we started, it was a 3, so it stays a 3. So this thing should turn into, that eraser. Ugh. 2 and 1/3. That should have been your final answer. How many of you got that? Okay. Some of you didn't raise your hand. I don't even know if some of you heard the question. For those of you who didn't raise your hand, did you not get 2 and 1/3? Did you get something else? Are you willing to admit where your error may have happened? Well, what happens when you have to turn something in to a mixed number, but the fraction that you get as your leftover stuff isn't in simplest form? Okay, so let's look at one of those, because that does happen. All right, I'm going to give you an example. Are you ready for this one? Okay, so my example for this one is, let me get rid of all this stuff really quickly. Okay, so my example of an improper fraction that needs to continue to be simplified is going to be 18 over 12. Okay, that's an improper fraction. Simplify that thing all the way and give me your final answer. When you got it, raise your hand or put your hand on your head and I'll come and see what you got. You're not done yet. I want to know who's done. Who's done?
I'm done. Okay, I'm done.
Where? You're not done.
I'm done.
Let me see. You're not done.
I'm done.
You got it. I got one guy with it. Where we at? Where we at? That thing's an improper fraction. What do you do with improper fractions? You cannot do the same thing if it's an improper fraction. Where's your final answer? You're missing something. You're missing something. So far, I got 1 out of the crew. You're not done yet. Nope. Now you're done. Where are you at? Nope. You got it now. We got 3 guys in the room. Nope, you gotta try again. 4 guys. Come on, girls. Where are you? Where's your final? Where's your final? Nope.
Oh.
Nope. Ooh, I got a girl involved. Nice job. Where? Nope. Now you got it. I got 2 girls on the team. Let's see. I'm getting closer. I think it's only 6. Yes, Tessa. Sweet. Still working. You're not done yet. Where you at? You got it. Nice work. You're not done yet.
I got it now. I got it
You're
now.
not done yet.
I got it.
You got it. Sweet. Nice job. Nope. It's all right. That's all right. Nope. All right. Let's check this thing out. Okay. Where you at? What's your final answer? But you need to put that with that. Don't just circle that. All right, let's check this out. Here we go. First off, the answer that you should have gotten was 1 1/2. That was the final answer. Now, hold on. So, what we had to do first, and I saw some of you make this big time error right from the start. 18/12 is what kind of fraction? Improper. So you can't start searching for the greatest common factor here. This is an improper fraction. Improper fractions, to put them in simplest form, it says we must use division to solve. So the first thing you should have done was try to divide this thing. So most of you did this in your head, but I had some of you who set it up as a division problem, and that's fine too. 18 goes in the box, 12 goes on the outside, and you just started to divide. 12 goes into 18 about how many times? One. 1 times 12 is 12. When I subtract, you stop singing. When I subtract, what am I left with? 6. That 6 is my leftovers, and it becomes my numerator. And my denominator is a 12. There were some of you who got to this part. But if I look at math as a race, okay, here's the finish line. Gosh, that little eraser thing is driving me bonkers. Okay, there's the finish line. For those of you who got 1 and 6/12, this is you right here. You just slipped and fell and never made it to the finish line. You stopped before you got to the end of the race. 1 and 6/12 is not finished because the fraction 6/12 is now something that needs to get simplified. 6 and 12 are both what kind of numbers, people? Composite. So in your brain, that thing is going off. 6 and 12 have a number that they have in common. So now we have to go back to what we learned in this first thing, which is how to simplify a proper fraction. Because 6 and 12, that's a proper fraction, isn't it? So what's the greatest number that 6 and 12 have in common? Some of you said a 2. Well, yeah, it does have a 2, but it's not the biggest one that they have in common. The biggest one they have is what? A 6. So you should have divided each of those by a 6. And when you do, what did you get? 1 over what? 2.
I just forgot to add it.
But what you have to remember is that this whole number right here, he's part of the answer. So he has to come over here with that 1/2. That is your final answer. Now, what happened to those of you who had this fraction? Okay, let me get rid of all this stuff that's kind of in the way. What happens for those of you who got that answer and said that they had a 2 in common? And you divided each of those by a 2. Okay? What did you get when you did that? You got 3/6. But 3 and 6 are still not done because 3 and 6 both have a number in common. What do they have in common?
3.
They now have a 3 in common. So now you have to divide each of those by a 3. And then you would get your 1/2.
That's just more one.
It is more one. Now I want you to notice that just because you didn't find the greatest common factor right from the start, it didn't mean that you were going to get it wrong. It just meant you had to do it twice to get to the finish line. Okay? If you would have chosen the biggest number first, like instead of choosing a 2 and then having to choose a 3, what's the biggest number that they have in common? The biggest number they have in common? 6. If you would have multiplied these together, what would you have gotten? 6. That would have been your biggest number. You can still get to the finish line. You just took longer to get there. It was like you just decided before you hit the finish line, you were just going to go to the restroom and maybe grab a Coke and then decide to finish. It takes longer. Okay? But you can get there. Now, how many of you honestly got 1 and 1/2 all on your own? That's only about 8 of you. So that means we got to try another one. Okay? Here we go. This time, Now that you kind of know what you know you gotta get to the finish line. Don't trip and fall before you get there, okay? I'm gonna give you another improper fraction, so that means you're gonna use division to solve. Ready? Your fraction is 20 over 18. Let me see. Okay, now you just haven't reached the finish line yet. This is, you're almost there. But this right here needs to be made smaller. Because that's the right answer. That's the right answer. You see working? Okay. Your leftovers become your numerator, and your denominator stays the same. Now, okay, what's your denominator? Now, simplify that fraction. Where is? Put this whole number next to your line on it. Oh my bad, I didn't see it. That's right.
Is that right?
Yes, that's right. You got it right. You got it right. Try that again. You divide, that's the right number, but if you divide this by that number, you should not get that number. Yes. What's this divided by that?
Oh my gosh.
Yeah. You got it. Okay, what did you get as your fraction? Yes. Okay, so that's right. And now I need you to take 2 over 18. How many of you got 1 and 2 over 18? Then 2 and 18 needs to be simplified, right? So look, Allie, this thing right here turns into 1, because 18 will go into 20 in one whole time. How many do I have left over? 2 over my 18, okay? But 2 and 18 are not in simplest form because they each have a great common factor. There's a common number between 2 and 18. What's the number that 2 and 18 have in common? Well, if I list my factors for 2, 1 times 2 is 2. Is there anything else I can multiply to get 2?
0.
What are my factors for 18? Well, 1 times 18 will give me 18. 2 times 9 will give me 18. Will anything else give me 18?
Yeah.
What?
3 times 6.
3 times 6 will give me 18. Anything else?
No.
No. So now look at your 2 lists. What's the largest number that they have in common? They have a 2 in common. Now that's the greatest common factor. So now I have to divide each of these by that 2. You see where I got that? What's 2 divided by 2?
That is 1.
That is 1. What's 18 divided by 2?
And that's 9.
That's 9. Xander, did you see where your little boo-boo happened there? Bring this big 1 over here next to that 1, 9. That's where your answer came from.
Yes, I
Good, good. Okay, now, how many of you got that one right? A lot more of you than a minute ago, okay? So just know, sometimes when you're playing with improper fractions, sometimes you gotta do a little bit more work before you get to the finish of the race, okay? How do simplifying fractions feel now?
Easier.
All right, let's move on to what's next, okay? We have 2 lessons left in this chapter, lesson 5-7 and lesson 5-8. We're gonna start lesson 5-7 now, but I'm gonna tell you we're not gonna finish it, which ultimately means you're not gonna have any homework tonight.
Thank you.
Because the assignment this evening would have been for you to have completed the entire lesson, and we won't get through the whole lesson today. But we will get through a part of it. Okay, so I'm gonna jump you to what is next. All right, what, Mason? Please don't talk. We're in the middle of class. Just because we're transitioning into something new does not mean you can open up the talk gates. So, what's your question? Yes. Not right now. No, it's not 10:30. I've said this all the time. 10:30 is snack. No, we switched it a long time ago to 10:30. Okay. All right. So here we go. Lesson 5-7. Now look, again, you learn through listening, not through writing. So take today and listen first. And then if we have to come back and write all that red stuff, we will. But for right now, title is all you need. So today we're going to start learning how to compare and order fractions and mixed numbers. Okay? And I'm going to tell you, we're only going to get through one part of this today. Okay? But just get the title down. Learning how to compare, which means we're going to look at two things and we're going to compare them by saying if it's greater, less, or equal. And we're going to do that in a really easy way. The book does not teach it this way. I'm going to teach it to you the easiest way humanly possible to do this. So if we were to use the book's way of learning, it would sound a lot trickier. This is going to be super simple. So honestly, don't start writing this red stuff yet. Okay? If you need it, we'll come back to it in a minute. But I want to show you what it means first. Now, some of you are really listening and some of you are not at all listening. I can tell because your attention is in other places. So this is the part where I talk about we have to start doing better as students. So I ate lunch with Miss Coley the other day. She's soon to be your math teacher in just a couple of years. We come from the same family, and one of the things that we have in common is it drives both of us crazy on a quiz or a test day for a student to come up and say, how do I do this? That is not the time to ask how to do something. The test and the quiz is supposed to be when you show what you know. It is not the day when a teacher is supposed to teach you how to do something. So if you're having to ask those kinds of questions on test or quiz days, then it means you're not doing your job and listening and paying attention while it's being taught. Okay? I get it. Math is not the most entertaining subject on the planet, but it's a choice to pay attention. You can choose to listen or you can choose to distract yourself by doing things you shouldn't, like pulling things out from your desk and doing things inside of your desk where it looks like you're paying attention, but really you're being distracted by whatever you got going on inside your desk. Or by laying your head down on your desktop and looking like you're ready to fall asleep. These are things that are not keeping you super involved. And that's going to end up being the reason why you don't understand some of this. Okay? So we're going to learn today how to compare two fractions. And they're going to be fractions that we are going to use these little 3 steps to figure out. What, Brady?
I was gonna say, can we like at least write down the steps because I personally myself,
You like that? Well, yes, you can, but let me show you how to do it first, and then I'll bring the steps back to you, okay? So step 1 says, all you have to do when you're comparing two things, and when we compare, we're talking about putting these symbols inside of the boxes, like the greater than, the less than, or the equal to symbol. The first thing that you're going to do is cross multiply fractions. All right, now that sounds kind of confusing, right?
I've seen you.
But, okay, this is actually not hard stuff. Why is it not going to the page I want? Okay, so let's take a minute and kind of look at what I'm talking about. So step 1 says you're going to cross multiply the fractions. Okay, so I'm just going to make up 2 fractions. So let's say that my fractions are, 3 over 8 is greater, less, or equal to 9 over 12. Okay. Well, one of the things I want to make sure you understand is that don't start paying attention to the size of the numbers. Like, don't look at 9/12 and be like, ooh, those numbers are bigger than 3 and 8, so 9/12 must be the bigger fraction. It's not that simple, okay? If it was that simple, you would have learned how to do this a long time ago, right?
Yeah.
So the steps say to cross multiply. So that means I'm gonna look at the numbers, and this is where the book does not teach it this way, but I'm teaching it to you this way. This will always work 100% of the time. All you have to do is look at the numbers that are across from each other, 3 and 12, and multiply those together. What is 3 times 12?
36.
36. Now you must make sure that you put the answer that you got to that above the right numerator. We just used that 3, so 12 times 3 got us 36. So we're gonna kind of put our 36 above that numerator we just used, okay? Let's go the opposite side. 8 times 9, 72. Now all you have to do is compare the products. So when we multiplied, we got a product of 36 on this side. When we multiplied this way, we got a product of 72 on this side. What's bigger, 36 or 72? 72. So in this example, 72, 9/12 is the larger fraction. What?
I got the same thing, so I did it a little different. I did 3 minus 8 equals 5.
No, no,
I feel like they'd be like the bigger number.
No. no, doesn't work that way. Okay? All right, let's try another one, all right? What if you had a situation like, I don't know, make up a fraction for me. Brandon, go.
12/16,
Okay,
and then 20/30.
let's do another, let's do 2/3. Just so I can show Sophia that her theory about subtracting two numbers is not the way she needs to do it, okay? All right, so we're gonna use cross multiply to figure this out. So we're gonna do 12 times 3, and we get what? 36 again. We get 16 times 2, what do we get? 32, right? Is that 32? Okay, what's bigger here?
12/16.
36 is larger than 32, so therefore that's the larger fraction, okay? So that's why, Sophia, I want you to understand, you were saying the difference between this was a 5, the difference between this was a 3, okay? So the difference works that way. I don't want you to think about, it doesn't have anything to do with differences, okay? This is how you compare fractions that are proper fractions, all right? So the steps, Brady, a minute ago that you asked about, just tell you that information. So it says, number 1, you cross multiply. Number 2, you put the product above those fractions. In step 3, the larger product is the larger fraction. Now, if you need those, copy those down.
What if they're equal?
Um,
If they're equal.
well, they're equal, then they're equal.
If they're equal, yeah.
But let me show you what an equal fraction would look like. Dominic, what's your question?
I just made another fraction for me to solve to have like more practice. And it was 3/4 and 2/4 and I got it equal. So I had a greater this way, a greater that way, and equal. So
All right, well, let's try this one, okay? You all try the example that I have here. 3/7, is it greater, less, or equal to 6/7? Equal. Use cross multiply to solve. So you're gonna multiply your 3 as a numerator by the 7 across from it and get what? What? 21. Go the opposite direction. You have the 7 as the denominator by the 6 as the numerator, and you get what's bigger, 21 or 42?
42.
So that means in this example, the first fraction is smaller than the second one. What?
So it's like 6/12 and 3/6, like an equal fraction.
Well, let's look at it. So she wants to know if, what'd you say?
I did 6 over 12 and 3 over 6.
Okay. So she wants to know if these are equivalent fractions. What's 6 times 6?
36.
36. What's 12 times 3?
36.
This is an equal fraction. But I want you to notice something. Who, except for me, notices that if I take the fraction 6/12 and I put it in simplest form, what am I going to get? Is this thing right here an equivalent fraction of 6/12? Yeah. Like, what could I do to this 3 to get a 6? What could I do to this 6 to get a 12? These are equivalent fractions. So that's why they're equal. But you can always just use cross multiply to solve. But yes, they're equal fractions. Okay? Now, any questions on how to take a proper fraction and compare them? No. All right, we're not done yet. I'm telling you, we're gonna finish one piece of today's lesson, okay? That's just the first piece.
How many pieces are there?
What happens if you have to compare not just proper fractions, but like in this example? So we know how to compare these proper fractions, but what happens if we have to compare a proper fraction and a mixed number? Okay, well, look at the little note off to the side. The mixed number is always going to be bigger because a mixed number is always larger
I
than
was
1.
gonna say that.
Yeah, I'm just like, yeah, it's kind of.
This proper fraction right here, we know proper fractions are always greater, less, or equal to 1.
Less.
Less. We know that mixed numbers are always greater, less, or equal to 1. Greater. So if you know that information, this fraction is always going to be less than that fraction. Do you even need to do anything? No. Now, if you tried to cross multiply this, it would not work. Won't work. Because you can't compare things that don't match. A proper fraction and a mixed number don't match. So you can't use that little trick in that situation. So try one of these. Ready? Okay. What if you had 8 over 15 is greater, less, or equal to 2 and 1 over 3? What's going to be the answer? Do you even need to write anything down?
No.
Carson, what's going to be the bigger answer? 2 and 1/3 is always going to be bigger because this whole number here automatically tells me that's the larger fraction. What?
It won't work if it's two mixed numbers.
We're going to get there. We're going to get there.
Whichever one's bigger.
Okay. So what happens when you're comparing things that match? Like what happens if instead of it being like a proper fraction and a mixed number, well, what if I'm comparing a mixed number and another mixed number? Okay, like 1 and 3 over 4 and 1 and 2 over 6. Well, now what am I going to do, Brady?
You would just cross multiply.
Just cross multiply.
They have the same.
They have the same whole number, so we can't use that as an easy answer. So now we have to go back to what we do with our proper fractions. Cross multiply. 3 times 6 is 18. 4 times 2 is 8. So is 18 or 8 larger? 18. So 1 3/4 is the larger mixed number. What?
Can you go back to the steps? I didn't finish copying.
Yeah, hang on. One last little example before Spanish. What if you have 2 improper fractions? Or wait a minute, let's play off one more. So let's say you have 2 and 1/2 is greater, less, or equal to 1 and 1/2. Which one's bigger? They're not equal.
It is.
This one has a 1 as a mix. This one has a 2. What's always bigger? 2. Okay? So the mix, always pay attention to the whole number first. All right, last one. What if you had two improper fractions? Like 12/7 is greater, less, or equal to 9/8. What are you gonna do? You just cross multiply. 8 times 12 is? What's 8 times 12, y'all know? 96. 7 times 9 is? 63. What's bigger? 96. So that goes with that. Okay. All right, you all good? That's just part one. So notice the title. The title says how to compare and order. All we've done is the compare part. So that's why there's no homework tonight, because we still have to learn how to order them. I'll leave this up here a second. If you want the steps, here they are. Yeah. You may get your snack out this time.
Hola.
Addison, I'll come back to this. Okay.
Zip your lips. If you have your snack out, that is A-okay. Keep your snack. We're gonna go to the bathroom when it's time for the bathroom break. But for right now, please go ahead and open up Google Classroom. We're gonna start with our piece of equipment for today. And then we are moving into our next room in the house. Today we are learning about two different things. The first one is La Cocina, which is, does anyone know? Okay, kitchen. And the second one is El Comedor. Does anyone know what El Comedor is? Brady? Not bathroom. Brody? Dining room. So we're doing the kitchen and dining room.
We're gonna design our own kitchen.
We're designing our own kitchen / dining room. Half the class next door did this. Half of them said that they want to combine it and make it all one room. Because some of them have like eating kitchens, so they put the dining room between the kitchen and things like that. Some of them said, I want two separate spaces, so they put a line down the middle of their slide. And half of it was El Comedor and half of it was La Cocina. But first, we need to learn the rooms for that. The rooms. The items